Okay, first I'm going to show you how to evaluate one-sided limits using the substitution method. All right, so this limit right here says the limit as x approaches -2 from the right. So if we're looking at -2, the right is this way, so that would be maybe -1.99999, and you could get as close as you wanted, but at some point that's too cumbersome, so you're probably going to not put that many, but I don't want you just putting -1.9. That's probably not close enough. So what we're going to do is I went out to the 10,000th place. I'm going to substitute everywhere there's an x. I'm going to substitute that -1.9999 in there and simplify. And this is the trick. When you plug a negative number and you square it, that's positive. What's a positive plus another positive number? These two numbers up here are going to be a positive number. And then this -1.9999, because it's smaller than +2, when you add those together, you get a positive. Well, a positive divided by a positive is a positive. And when we have these rational functions, and we're finding the one-side limit, what we're looking for is what is the end behavior doing. So remember, if you've got a one-sided function, you might have an asymptote there. At -2, you're going to have an asymptote. You might even have a third asymptote. And if your graph looks like this, if those are the asymptotes, that graph would maybe look like this. And look like this. So look at what it's asking. What is the behavior doing as you get really close to -2? Whoops. As you get really close to -2, what is happening? Now we're on the right side right here. Look at what that behavior is doing. It's headed towards positive infinity. Okay, so rational one-sided equations using substitution, you just pick a number that gets really close to zeroing out the denominator. So a number really, really close to 2 from the right side, or -2, excuse me, was that -1.9999. We substituted it in, and we ended up, all we're looking for is, because we know we're close to an asymptote, we're looking for, is it headed towards positive infinity or is it headed towards negative infinity? And when you substitute it in and you get a positive divide a positive, that's positive infinity. If this would have been a negative down here, if we would have plugged in 2.0001, if this would have been from the negative side, so this would have been -2.0001. Well, this down here, this would have been negative more than 2 plus just 2. This would have been a negative down here. And this negative squared is positive. Positive plus positive, this still would have been positive. Well, positive divide negative, that would have been a negative infinity. And you can see from the left of this asymptote, so if the asymptote is here, and this is -2, coming from the left, that function is headed towards negative infinity. So using substitution on one-sided, this is kind of a quick way to determine. It's also always a good idea to put these functions into Desmos to see what the graph would look like. That will help make your decision too, but in a test situation, if you don't have a calculator or a way to put that into a Desmos or some other graphing device, it's hard to do that. But if you know this trick, or this method I should say, you can get the answer correct every time.